This is the best AP Physics practice you are going to get before the exam, and I'm going to walk you through it step by step, Michael style. All right. So here are my qualifications. I have five in AP World, 1460 PSAT with perfect math score, and a 1480 SAT with 780 English. So why I decided to make this is, well, they say like that once you're able to teach a subject and you're truly ready for what is to come. But I don't think I'm ready to do either of those things if I'm gonna keep it a buck with you. Like, honestly, I just want to teach it because, frankly, it makes me understand it a little bit better, and also you guys also understand it better too. I think this is a lot better than if you were to try to study at school, because like school, psychologically, do you really get work done at school? The answer is no. All right, so with that being said, lock in with me until the end of the video. Don't play it in two times speed. I know you guys are brain rotted like that. Have a pencil, paper, and let's go. Okay, here's the formula sheet. Feel free to go back in the video if needed. And here's something you need to know about the formula sheet. If on the exam day you are like looking at the question and then you're like, hey, oh, this one has acceleration. This one has momentum. Let me look at the equation sheet and see which one has acceleration momentum. You are cooked for the exam. I'm gonna be honest. You are cooked for the exam because if you don't already know it conceptually, what makes you think that they're just gonna give you a question that you can just plug and chug with the equation sheet? No, they're gonna do some stupid stuff where you have to like manipulate the equations with each other and then you get the right answer. So if you have to refer back for these like basic equations, you're cooked for the exam. I'm sorry. The exam format, I don't think she's talked about this once in class. This is really important because if you do terrible on the MCQ, but you do have like an insane FRQ, you're still getting a three, right? Minimum of three. And the thing is that these graders are super lenient, right? You have to put yourself in the grader's shoes. They're looking to give you points. They're not trying to remove points. They're trying to add points to your score. So there's only four FRQ questions. Okay, each one maybe has like two or three parts. If you do good on these four FRQ questions, that can carry your AP exam, and that can be the reason why you get a five out of four. Right? The MCQ, bro, it really doesn't matter. Okay, like even though it is 50%, those four questions have 10 times the weight than the other 40 questions on the multiple choice. So it's a lot easier to do good on FRQ than it is to do good on the MCQ. All right, so I'm going to give you guys some time to read the question. Please pause the video, and when you are ready, um, we can get started. So it should take you about 30 seconds. Okay, so for this question, it looks confusing at first because there's springs and there's two blocks, and it's all about magnitude of forces and whatnot. So, first of all, it's asking for the up force, the down force, and gravity. So, the up force, in this case, because it doesn't say anything about springs, we just cross them off. I mean, we kind of do have to worry about them, but like, just don't, for all intents and purposes, just don't worry about it for this question, right? So for this one, the up force is going to be the force that X exerts on Y, right? And then the down force is going to be the force that Y exerts on X. And because of Newton's third law, which is every action has an equal and opposite reaction, right? Which means these two forces are equal. The up force is equal to the down force, okay? Which means it can either be A or D. So now, to determine whether or not it's A or D, we need to see, is it greater than the force of gravity or is it equal to the force of gravity? What we need to realize is that after it reaches all the way down, it's going to go upwards, right? Because it's a spring, it's going to propel upwards. And what does that mean? That means basically if it has enough force to accelerate upwards after it's compressed by the spring, that means it has enough force to exceed the force of gravity, which means it is greater than the force of gravity, which means A is the correct answer. All right, for our next question, it's going to be the same thing. I'm going to give you 20 seconds to read the question, and then we'll go from there. So, for this question, it's talking about instantaneous acceleration. And me, I'm in pre-calculus. I don't know what like derivatives and stuff is. I looked it up. It's like A equals dx or something. Okay, like derivatives. And I have no idea what derivatives. r. But I do know what acceleration is. What is acceleration? Change in velocity over change in time, right? So, what here can give us the acceleration, velocity, and time? So let's see. A gives us total distance and the total time. Oh, wow, we have time, but we don't have velocity. It says nothing about velocity. So we can already cross this off. Okay. B, the final speed. Oh, we need speed and the total elapsed time. Oh, it could be this one. Very might, very high possibility it's this one. Okay. This one. Distance between the points. These points, right? Just before and after the midpoint and the time. So it gives us time, but distance. We don't need distance. We need velocity. And this one, the speed. Oh, we need speed just before and after the midpoint, which is these ones right here. And the time. So which one here, B or D? The reason why it is D and not B is because V final and T have nothing to do with the acceleration, right? If you're only given V final and you're not given in V initial, then you can't find delta. Okay, so the V final really means nothing, which means it is D. Okay? All right, for this next question, it's talking about block, how that rests, spring, whatever. So I'm going to give you 20 seconds to read over this question, and then we'll get to it. So go on ahead. All right, so for this question, it's asking about potential energy and kinetic energy. So what are the formulas again? You don't even have to look at the equation sheet. It should be in your mind. It's PE, potential energy, is equal to mgh, and kinetic energy is equal to 1/2 mv squared. And look, there's no like numbers. It's all just variables and constants and whatever, right? So we need to understand this conceptually. This is what I was talking about in the beginning. So potential energy is mgh, right? So the mass of the block at point C, how does it compare to point A? Well, it's the same block. It doesn't get swapped out or anything. So the masses at point A and point C are the same. So you can cross them out. Gravity always stays the same. And H and H, they're the same. They're at the same heights, which means the gravitational potential energy stays the same throughout the system at both point A and point C, which means it has to be A or B because look, they're the same, which means it can't be C and it can't be D. Okay? Now, kinetic energy equals 1/2 mv squared. What is the kinetic energy at point A? It says it is held at rest, which means velocity is 0. Velocity is equal to 0, which means the kinetic energy also equals 0, because if there's a big fat 0 here, that means everything else becomes 0. Okay? Which means that if it's A, then this one also has to be 0. And if it's not, then it's B. Right? So, is there any point where it says it stops at point C? The answer is no. It just says slides along the track until it passes point C. It keeps going, which means the velocity is not 0, which means the kinetic energy is greater than 0, which means, boom, it's exactly what's in choice B, which means the answer is B. Okay, so this is one of my favorite questions ever, okay? And if you can get this one right, like confidently, and you don't even need my help, that is a very good sign that you're doing good, because this has a lot of conceptual details about it. So let's just get started. I'll give you a whole minute to read the question, right? All right, you got that. If you got this one right, I'm proud. But this is okay. Enough glazing. So first, it's asking for the height. So when I first saw this, and I was like an amateur, the way I did it, I just saw, hey, I'm gonna draw a line over here, and I'm gonna compare it like this. And oh, it looks like this one is about h, and this one is another h, right? They're about the same, which means it's 2h. What's h? 0.4, you know? So I was like, what's double 0.4? 0.8. What's 0.86? And turns out that is the right answer. But, I mean, here's another thing, right? Anytime it says figures are not drawn to scale, they're always drawn to scale. Like, I promise you, they're always drawn to scale. So what I just did, you can definitely do that. But don't do it.
because there's a much easier way that doesn't involve. Because like, what if it wasn't drawn to scale? But anyway, what you want to do is you want to use energy conservation. So how do you do this? You want to do uh, mgh at zero point 0.1 plus kinetic energy at zero point 0.1 is equal to potential energy at zero point 0.1 plus kinetic energy at zero point 0.2. So potential energy at zero point 0.1, what is the mass? It gives it to us. Oh my gosh, there's finally numbers. So 0 0.2. Okay, perfect. Gravity, we're just gonna say 10. I don't really care. And then uh height. Height is just a freaking constant. So we're just gonna write K. Or H. K, it's held at rest, right? So kinetic energy, like we just said in the previous question, 0 plus 0 equals mgh plus k. So same as usual, 0 0.2, because the mass stays the same. Gravity also stays the same. And the height, it's also given. Thank goodness, 0 0.4 plus kinetic energy, which is 1 half mv squared. The mass is 0 0.2, 0 0.2 times velocity. Velocity, so now we're just going to simplify. 2h equals 2 times 0 0.4, which is 0 0.8, plus, oh, this needs to be squared, mb. That's 0 0.2 is 2 over 10. It's 1/10. Yeah, I'm kind of slow. 9. 2h equals, is this 0 0.8? 0 0.2, 2 times, yeah, okay, 0 0.9 plus 0 0.8. 2h equals 1.7. H equals 0 0.85. And yeah, that is basically exactly the same. Great job if you got that answer. You could just use common sense and do what I just did, but don't recommend it because, yeah. But if you're wondering, hey, Michael, you're an idiot because it's actually 0.86 and you got 0.85, remember I used 10 for gravity and not 9.8, which is probably why it's a little bit different. But even, yeah, if you ever see it's like one decimal point off, you're probably right. Also, it says most nearly. Okay, anyway. Next question. Okay, next question. Next question. The magnitude of the gravitational force exerted on the block is Fg. And okay, whatever, you already read the question. So it's asking, is the normal force greater than the force of gravity? Is the normal force equal? Is whatever. So it's asking at its lowest point, which is like right here. What you need to realize is that we are like basically in a circle. Like just pretend there's like an imaginary circle. And what do we know about circular motion? Anytime an object, whether it's a ball, it's a square, it's whatever, any object that's traveling in a circular motion is going to have acceleration towards the center. The velocity is going to be going this way and the acceleration is towards the center. And acceleration is equal to force over mass. Acceleration is directly proportional to force. Directly. If we increase the acceleration, the force also goes up, right? Like let's say F equals 10 times 1. If we increase it to 2, then it's going to go to 20 instead of 10, right? It's obviously going to increase. So the normal force, let's draw a free body diagram. There's always going to be force of gravity, which is mg, and there's going to be an equal and opposite force, which is the normal force. And then, so if it was just these two, you would be right if you selected B, but that's wrong because you are moving in a circular motion. And we know there's always acceleration towards the center, which means the up force, which is the normal force, is going to add on to this centripetal force, which means the normal force is greater than the force of gravity, which means it's A. If you got this right, great job. Because, yeah, great job. Next question. After the block leaves the track, what is the block speed when it reaches the highest point of motion? Okay, this one is really, really important. Okay, I'm going to erase this real quick. Let me put the answer back. It's 0.86. This is really, really important. So, first of all, anytime you have anything that's added data, I know we hate like trig, right? we need to understand that if a force or a velocity is going this way, diagonally, it is comprised of two forces. The up force, or the, forgive me, the perpendicular force and the parallel force. Okay? Super easy. All you need to remember is that sine is equal to y, and then cosine is equal to x. So this one, there's an imaginary x and there's an imaginary y, right? So this force is going to be 3.0 times cosine 30. Frick, why did I write theta? Cosine 30. So that's the velocity. And then try to figure this one out yourselves. If this one is 3.0 times cosine 30, what is this force? Well, we know that sine is the y direction, right? So all you need to do is it's 3.0 times sine 30, right? Okay? So just remember that. If it's in the x direction, that's cosine. If it's going up, it's sine. Okay? Are you good? Yeah. Anyway, now how is this all important, right? So it's talking about, if you want to read the question again, after the block leaves the track, what is this block's speed when it reaches its highest point? So just pretend the block is going in a parabola, and when it reaches its highest point, okay? So right now, the upward velocity is 3.0 times, what is it? What is it? What is it? Sine 30, right? Because it's in the y direction. But gravity is going to oppose that force. So it's going to be decreasing, decreasing, decreasing. Okay? So that 3.0 sine 30 is going to go to 2.0, then 1.0. And then finally, once you get all the way to the top, right? The vertex, the highest point, it's going to be 0. Okay? You really need to understand that. Vy equals 0 at the highest point. It's going to go from 3.0 sine 30, 2.0, 1.0. It's probably not, but you get the point. So now the only thing we need to calculate is the horizontal force. Okay? Horizontal force never changes. It never changes because air resistance is negligible. Okay, just, I don't care if you don't know what that means, just remember that. Horizontal force never changes. Okay? Vertical force does because there's gravity. Horizontal force doesn't change. So now what can we do? We need to find the block's speed. So if the vertical velocity never changes, what is Vx? It is 3.0 times x. What is x equal to again? X is equal to cosine. So cosine 30 degrees. And cosine 30 is root 3 over 2, which is about 0.8 times, I'm wrong. Okay. Yeah, it's 0.8. Yo! Okay, I'll cut this out. Cosine 30. It's 0.86 times 3. What is 0.86 times 3? 2.4 plus 0.18 equals 2.58 meters per second. When it is at the highest point, we need to know this. We need to know this. Okay? 2.58, 2.6, same thing. I don't care. I'm right. All right? Listen, if you got all 3 questions right, bro, you're locked in on forces and energy because you did that too. So, what can we take away from this, right? What can we take away? We can take away that energy conservation for number 1. Energy conservation. That's for number 1. For number 2, centripetal acceleration always points towards the center of the circle. So if the ball's over here, it's always going to point to the center. Okay. Third one, super important, is all about vectors. If there's a diagonal vector like this, there's always going to be a vertical and a horizontal vector. Does horizontal velocity change? Right. Yeah, right. No. Horizontal velocity never changes. Because think about it. Is it affected by resistance? No, there's nothing that affects it. Does vertical velocity change? Indeed it does, because the force of gravity always opposes it. It always opposes it. So it's always going to go, it's going to approach zero, if you get my drift. Yeah. It's going to approach zero. And then also, what is velocity in the x direction? Cosine. Super important. Sine. I always hated how she did how she never explained this. Maybe because I'm dumb, but like, this is all you need to know. Okay? X is cosine, y is sine. All right? Good? Good.